Good morning, students. Now I am going to take a graphical solution method in type 2. In previous lecture, what I told you, that is the graphical solution method in type 1 method. Now is the type 2. What is the difference between type 1 and type 2? Well, just a simple difference. In type 1, all the subject to the constraints are less than or equal to constraints. In this model, 1 or 2 is less than or equal to, or greater than or equal to, and greater than or equal to. So, in this example, minus 2x1 plus x2 less than or equal to 2 and 3x1 plus 4x2 greater than or equal to 12. So, one is the less than or equal to type and one more is a greater than or equal to So, this problem belongs to graphical solution method in type 2. Okay, now we have to find the solution. So, as usual in the same method in previous problems, graphical solution method in type 1 method. So, what is this? Minus 2x1 plus x2 is equal to 2 and 3x1 plus 4x2 is equal to 12. So, this is the equation 1 and this is equation 2. In equation 1, so minus 2x1 plus x2 is equal to 2. Put x1 equal to 0. So, what we get? X2 equal to 2, that is 0, 2. And put x2 equal to 0, that is minus 2x1 is equal to 2. So, x1 is equal to minus 1, that is minus 1, 0. So, what are the pair of points in equation 1? So, 0, 2 and minus 1, 0. So, equation 2, 3x1 plus 4x2 is equal to 12. So, put x1 equal to 0. by 4, x2 is equal to 3, that is 0, 3, and put x2 equal to 0, that is 4, 0. Now we are going to plot the graph. So, what are the points? 1, 2, 3, 4, 5, 6, 1. So, 0, 2 minus 1, 0. 0, 2 minus 1, 0. Next point, 0, 3, 3, 4, 0. That is this point. So, these 2 points are not intersecting and these equations are greater than or equal to. So, what is meant by greater than or equal to? Suppose for example, x greater than or equal to 5 means the point belongs to 5 and the greater than or equal to 5, 6, 7, etc. up to plus infinity. So, what is the mean by greater than or equal to up to infinity? So, we are not able to find the bounded area. So, bounded area. So, first of all we have to find the bounded area and then we find the boundaries. So, in this problem there is no feasible solution because one constraint belongs to greater than or equal to type. One constraint belongs to greater than or equal to type. There is no feasible solution here. There is no feasible solution. Now, we are going to see another one example in the same type. Now, let us see the another one example of the same type, that is the graphical solution method type 2. So we are going to what I told in the previous problem, x1 plus x2 is equal to 1, 0.5 x1 plus 5 x2 is equal to 10, because the one constraint are less than or equal to, another one constraints are greater than or equal to. Okay, that is the equation 1 and equation 2. Put x1 is equal to 0, so x2 is equal to 1. Okay, so x2, put x1 here is equal to 0, that is x2 equal to 1. What is the point? 0, 1. Another point, put x2 equal to 0, that is x1 equal to 1, 1, 0. So these two pair of points 0, 1 and 1, 0. Put x1 equal to 0, that is 5 x2 equal to 10, x2 equal to 10 by 5, that is 0, 2, and put x2 equal to 0 in equation 1, 0.5 x1 plus 5 x2 equal to 10. Here x2 equal to 0, that is 0.5 x1 is equal to 10, x1 equal to 10 divided by 0.5, that is 100 by 20. So x2 is equal to x1 is equal, that is 20, 0. Now we are going to plot the graph. x1, x2. So what are the points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay. What is the first set of points? 0, 1 and 1, 0. Another set of points 0, 2, 20, 0. 20, 0, 2, 20, 0. That is, these are the unbounded, that is the unbounded area, not is a bounded area. So these two equations doesn't intersect. Okay, because one equation belongs to greater than or equal to and one equation belongs to less than or equal to. So these two equations doesn't intersect. So we are not able to find the maximize z. So there is no feasible solution. There is no feasible. Now express the following LPP in canonical form. What do you mean by canonical form? So questions maximize, all the questions are in maximize and subject to the constraints are in less than or equal to type. And some constraints are unrestricted. That is, unrestricted means x2, suppose x2 is unrestricted, that is x2 dash minus x2 double dash. That is the convert the following LPP in canonical form. That is a simple problem. So x2 is unrestricted means x2 equal to x2 dash minus x2 double dash, because restricted. x2 is unrestricted. So x2 equal to x2 dash minus x2 double dash. So you have to change in all this equation for x2 equal to x2 dash minus x2 double dash. So what is x2 dash minus x2 double dash greater than or equal to 0. So maximize z is equal to 2x1 plus 3, what here x2. So what we are changing, x2 dash minus x2 double dash plus x3. In a subject to the constraints, 4x1 minus 3 into x2 dash minus x2 double dash plus x3 less than or equal to 6. That is 4x1 minus 3x2 dash plus 3x2 double dash plus x3 less than or equal to 6. So you have in equation 2, you have to change the greater than or equal to in less than or equal to type. How can we change? Just you have to change the sign or multiply the minus 1 in all the sides, both the sides. So minus x1 minus 5x2 plus 7x3 less than or equal to 4, and you have to change minus x1 minus 5 into x2 dash minus x2 double dash plus 7x3 less than or equal to 4. So minus x1 minus 5x2 dash plus 5x2 double dash plus 7x3 less than or equal to 4. So what are the variables involved in this problem? x1, x2, x3. So x3, x2 dash and x2 double dash, all the constraints are non-negative. That is x1 comma x2 dash, x2 double dash, x3 are greater than or equal to 0. That is the solution of the problem. This is the simple problem. Now, we are going to see the another one example in standard form. In previous problem, we have to see the canonical form. Now, we are going to see the standard form. So, first of all, we have to change the minimize z into maximize z. That is, maximize z is equal to minus of minimize z. Okay, that is maximize z is equal to minus of 2x1 plus x2 plus 4x3. That is minus 2x1 minus x2 minus 4x3. This is a maximize z. Okay, this is maximize z is equal to minus 2x1 minus x2 minus 4x3. Next is subject to the constraints. Minus 2x1 plus 4x2 less than or equal to 4 and 2x1 plus 3x3 less than or equal to 2, x1 plus 2x2 plus x3 greater than or equal to 5, and x3 is unrestricted. What I say unrestricted means, x3 unrestricted means x3 is equal to x3 dash minus x3 double dash. That is maximize z is equal to minus 2x1 minus x2 minus 4 into x3 dash minus x3 double dash. Okay, so that is minus 2x1 minus x2 minus 4 x3 dash plus 4 x3 double dash. Okay, next equation 1. So now we introduce the slack variable for equation 1 and 3. That is x1, x2 already present, x1, x2, x3 already present in this problem. Now we introduce the another one variable, that is x4. So now we introduce the slack variable x4 greater than or equal to 0 and x5 greater than or equal to 0 in the first and third inequality. And the surplus variable x6 greater than or equal to 0 in the second inequality, because we are introducing the slack variable for less than or equal to constraints and the surplus variable x6 greater than or equal to 0 for greater than or equal to 0, surplus variable. Okay. So, minus 2x1 plus 4x2 plus x4 is equal to 4. So, next x1 plus 2x2 plus the x3 is unrestricted. So, unrestricted means what we are x3 dash minus x3 double dash minus xx. So, slack variable in terms of plus and the surplus variable in terms of minus is equal to 5. Now, 2x1 plus 3 x3 dash minus x3 double dash plus x5 is equal to 2. So, these are the form. These are the standard form. So, what are the variables here? x1, x2, x3, x4, x5 and x6 greater than or equal to 0. I hope you all understand the graphical method type 1, graphical method type 2, canonical form and standard form in this video. Thank you viewers. Thank you so much.